we have seen what is the force experienced by a body, or the force of attraction between two bodies, gravitational force of attraction between two bodies. It was G, universal gravitational constant, m1 m2 by r square, where r is the distance between the two bodies. Now from here we'll understand what is gravitational field intensity. Gravitational field intensity, it is like electric field that you study in electrostatics or electrodynamics. So what is gravitational field intensity? Suppose this is a body of mass m. Anybody with a mass will experience a force because of this body, because of this mass. Okay, so the distance, if we take some distance from it, what happens? This force is inversely proportional to the distance. So as the distance increases, this force decreases. There will be a point where this force will not be perceptible. So the area around a body up to which the force, gravitational force of that body is perceptible, is called gravitational field. So if it is perceptible up to this point, then we say this is its gravitational field. Okay, and since we have a field, we'll have intensity at any point. Intensity, gravitational field intensity at this point will be more than this point because this point is distant from it. So how do we find it? We say the force experienced by a unit mass. Let this be a unit mass. So the force experienced by a unit mass at a distance r from the body is its intensity. Generally it is represented as E minus. Why minus? Because this force is always attractive. So minus, we know this will be Gm into 1. The force is, we know, G into m1 m2 by r square. So the second mass is unit. So 1 into 1 by r square. So this is gravitational field intensity at a distant r from the body. If this is a sphere, we take it from the center. Clear? So this is electric field intensity. Field is what? The point up to which we have this gravitational force perceptible. This force can be experienced at this point. So that is field, and its intensity is this Gm by r square. That is the force experienced by a unit mass at a distance r. Okay. Now from this we have concept called potential, that is gravitational potential. If you have studied, you have seen these terms in electrostatics and electrodynamics also. What is gravitational potential? Now we know the energy at this point, intensity at this point. Obviously it will have a potential. Any particle will have a potential if it is placed in a field. So the work done, I am giving you the definition of gravitational potential. The work done in bringing a unit mass from infinity to that point, let's say this point, this is the point where we want to know what is the gravitational potential. So gravitational potential is the work done, let's say it is dw in displacing by dr, a small distance. So the work done in bringing a body from infinity to that point is the potential, gravitational potential of that point. Let's say we have to do a work dw in displacing a unit mass by dr. So how will we take potential? It is v. It will be, you know this, it will be from infinity to r, Gm by r square. This is the intensity. So this is how we find. When you will solve this, you will get V is equal to minus Gm by r. Okay. So potential at a point which is r distant from this body is this Gm by r. This is the potential at this point. And what is the definition of potential? The work done in bringing a unit mass from infinity to this point. So this is V, and if we want to know what is the potential energy, that's a potential energy of a body at this point, and the body is not a unit mass body, it is, let's say its mass is m1. So we know it will be Gm by r is for unit mass. So for m1 it will be m into m1. So this will be the potential of a body which has a mass m1. So I think this is clear. What is gravitational field, what is gravitational field intensity, what is gravitational potential, and its values. Okay. Now from here you can understand one thing, that E is, see, this is EDR. If you look at properly, this is what it is, EDR. Your dV is EDR, not dV. V is EDR, or E is minus dV by dr. So this is another relation. If you know what is E, you can find what is V, you can find E. So E is also the space rate of change of potential, gravitational potential. Okay, from this expression we can define E as the space rate of change, space rate, not time rate. This is distance. So space rate of change of gravitational potential is your electric field, sorry, gravitational field intensity. Okay, now let's see a very interesting result from this. Let's say the mass of Earth is me and its radius is r, and you know what is gravitational constant, G. Then this E, the gravitational field intensity at Earth's surface, will be from this equation minus Gme by r square. Clear? If this is Earth on the surface, it will be, the gravitational field intensity will be this. Now let's see one more relation we had seen in the last session. What is the force of attraction of a body of mass m on Earth? It is mg, that is the weight, and this is actually equal to what? It is equal to G m by r square, that is the gravitational field intensity, gravitational force. So this force is equal to mg. This we have seen. From here we see G is equal to Gme by r square. Okay, now we know this minus indicates attraction only, nothing. The significance of this sign is that it is attractive force. Now this is Gme by r square, this Gme by r square, that is E is actually equal to G mod. The magnitude is actually equal to G. So we also call this acceleration due to gravity is also called intensity of gravity. Intensity of gravity. So if you are asked why G is called intensity of gravity, this is the reason it is called intensity of gravity. Now second, let's see our potential. What will be the potential of this body of mass m at Earth's surface? We have seen potential is this. So at Earth's surface, this will be Gme by r. This will be for unit mass, and into m will be the potential will be, just you can say this is the potential of, this is the gravitational potential possessed by the body, possessed by a body of mass m at Earth's surface. Okay, again I'm saying gravitational potential possessed by a body at the Earth's surface. This is this. Now you can see this. If you multiply it, this is what? Gme by r. This is gr. Clear? This is what? This is gr. So if you take this out, what will this be? This will be gr. So the potential, gravitational potential possessed by a unit mass at the Earth's surface is gr. E is G and V is gr. Minus is for explaining that it is attractive. Okay, clear? So you should keep these two expressions also in mind. We have a question. It says there are two bodies, m1 and m2. We have a point, let's say this is the point P, where field intensity, gravitational field intensity is 0. Okay, let's say this, which is x distant from m1, and naturally it will be d minus x distance from m2, because the distance between the two is d. So we have to find potential at P. What is potential at P? D is given, m1, m2, d is given. We have taken this x, that at a distance x from m1, the potential will be, the gravitational field intensity will be 0 because of these two bodies. We have to find what is the potential. So we will have to evaluate or calculate what is x. How we will do that? E at that point is 0. That is, E at that point is 0. What is the meaning? It means gravitational field intensity because of this m1 will be equal to gravitational field intensity because of m2. What is this? G m1 by x square. This is gravitational field intensity at this point due to m1, and G m2 by, we have d minus x. This is the gravitational field intensity due to m2. So these two are equal, then it will be 0. So this means x by d minus x square. See this side, so this will be m1 by m2, or this is square becomes root to this side. Okay, So this is root m2 x equal to root m1d minus root m2 x. So from here what we get? X is equal to root m1d by m1 plus m2. m2 this side m1, this is m1. So root over m1 plus root over m2. So this is the relation between x and d. Okay. So when we'll find potential, we'll need okay, and we'll need to know d minus x, what it is. See, when to this side, root m1d will cancel and we'll have only root m2d. So d minus x will be root m2d by this root over m1 plus root over m2. Okay. Now let's find the potential at that point. The potential at this point P will be due to m1 and m2. So this will be minus g m1 by x minus g m2 by d minus x. This will be the potential unit variable. So let's say we take out minus g. So this will be m1 by x. X is root over m1. Okay. Into d into we have root m1 plus root m2 plus m2 by d minus x. So this is by root over m2, and here you have root over m1 plus root over m2. Okay. See, we can take minus g root over m1 by d out. Okay. So when you take this out, what you'll have? Root m1 plus root m2. See, this is root m1, this is root m2. So this becomes a square of this. So this is our value. Potential will be this minus g by d root over m1 plus root over m2 square. Okay.